Hello everyone. In this video, we will be talking about two pointers. So, two pointers is a concept where we use two pointers, basically two variables in our algorithm to solve a problem. So, two pointers is not basically a particular algorithm, but it is a concept. Now, two pointers can be used in multiple scenarios where we need to check the values of two cells of an array, or we need to check two different cells of two different arrays, right? Now let me give you an example. So let's say we have a question like we have given an array as an input. Let's say this is an array 3 2 5 6 1 and let's say 0. And we have been asked like give me two uh, give me the indices of two numbers where the sum is equals to 7. So how can I do this? To solve this problem in a very brute force manner, what I can do is I can run two for loops. Like the first for loop will will be pointing to one index, and the other for loop which will be running just inside this for loop will be searching throughout the array whether I have the complementary number which can go with the one that is pointed by, let's say, I. This for loop is having the index or the variable which is iterating through the array as I, and let's say this for loop, the one which is inside the parent one, is having j as an variable which is traversing through the whole array. Now, the index that is pointed by I has some value, right? Let's say it has value 3, or it has value 2 at some point of time, or it has value 5. So I want to know whether in my array, do I have the complementary of 3, which can make the total as 7, like 4. Do I have 4 in this whole array for this particular 3? So I will be searching using this for loop. So I won't find 4 here. So next time when I go for 2, I need to find 5. So yeah, I have 5 in it. But the overall time complexity of this whole algorithm becomes of n square, which is a quadratic solution. And of course, the interviewer will ask to optimize the solution. So where what we can do is I can basically sort this whole entire array, and the sorted array will look like 0, 1, 2, 3, and 5, 6. Now what I can do is using the concept of two pointers, I can point one pointer to the initial index and the second pointer to the end. So let's say this pointer is I and this pointer is J. Now what I can do is I can check whether the summation of the values that are present in my current pointers gives me the ultimate result. So let's say in pointer, the value present at pointer I is 0 and at j is 6. So summing both of them will give me 6, but not 7. So what I need to do is, as this array is already sorted, I know that the value which I need is not 6 but 7, which is greater. Now to get a greater number, should I move my lower pointer to right or my higher pointer to left? Of course, my lower pointer to right, right? Now I moved my I to, let's say I moved my I here. Now what I can see is, yeah, I have the summation of both I and j as 7 right now because 6 plus 1 is 7. So yeah, I got my answer. So solving this problem with two pointers approach will give me lesser time complexity than n square, which is big O of n log n. Why? Because as I've already said that the input array is not sorted, or I've not even mentioned that the input array will be sorted. So what I need to do is to implement my two pointers. First of all, I need to sort my array, my input array. Then I need to implement this two pointers approach to solve this problem. So this is a famous problem which is called as two sum problem, which you can find in lead code as well. Now, moving on to another case where we can use two pointers, right? So let me remove all this first. Yeah. So let's say I've been given two ordered array, which is in non-decreasingly sorted. From non-decreasing, I mean I can have two values in the array which are equal. So let's say I have 1, 4, 6, 2, not 2, 7, and 8, 10, 12, and 15. So let's say I have this array. Let's say let's call this array as A, and let's have another array, 7, 17, 21, 25, and 30, let's say. So this is also in a non-decreasing ordered array, and this is also the same. So let's say, let's call this as P. Now what we are supposed to do is we need to merge these two arrays in such a manner to make a third array where the values in the third array will also be in a sorted manner. So the end result will look like this. So how can I do this? The brute force approach, what I can think of by getting to know this problem is just put all the values that are present in array A and array B to the third array. Let's call it C, and sort the whole array. So how much time does it take? Basically, inserting all the numbers in the new array will take big O of n plus m, where n is the length of this array A, and m is the length of array B. Now this is the time complexity to get all the values in array C, plus to sort the whole array it will take me big O of n plus m log n plus m. So excuse my handwriting, guys. This is very messy, I know, but I can't do anything because I have this mouse only with me. So yeah, this is the whole time complexity of the algorithm to do this. But what if I say I can do this within the time complexity of n plus m, basically linear time complexity. I don't need this sorting one. How can I do this? Again, with the help of two pointers, what I can do is I can point one pointer to the initial position in the array A, and similarly I can point the another pointer. Let's say this is I and this is J, and what I can do is I can create an array of size n plus m before starting of the iteration. And what I can do is then start the iteration. How will I iterate through this? Let's say um, in the initial position, what I can put is either the value which is present in uh, which is pointed by the pointer I or by pointer j, because What I need at an as an end result is either uh, so as an end result, what I need is to be the whole array as sorted. So the initial value of the array will be obviously the least value, whichever is present in array A or array B. Now I can get the value that is present in either the first position of array A or first position of array B. Now I will compare these two values. If the value that is present in array A is lesser than the value present in value B array B, which is in this case, I will place the value, and then I will increment this pointer one value up, which is I will be initially pointing to 0 and now it will be pointing to 1. Similarly, again 4 and 7 I will be comparing. Now 4 is lesser than 7, of course, so I will be placing 4 in the second position. Again, I will be incrementing the pointer I to 2. Now, again comparing, the value 6 is less than 7, so I'll put 6 here. Similarly, going forward, now what happens is the value that is present in A and B pointed by the respectively I and J are same right now. But what I can do is either I can place any of the values. Like if I place the value present in B, so I will be incrementing J to 2 here, right? And or I could have placed the value that is present in A, but it doesn't matter, right? So moving forward, again I will compare the value that is present in B and A, it's 7 and 17. So I'll put 7 here and again move this pointer. So I think it is pretty clear like how would we approach to this problem using these two pointers. So basically at the end, like how much time am I taking to complete this whole algorithm or to finish this whole process to get all the values from A and B into my end result. That is, I will be traversing my first array once and the second array once. So the length of whatever is my first array and my second array will be added, and hence the time complexity becomes n plus m. I think the approach is pretty clear. We will be discussing some problems after this video, uh, in the next video, and yeah, we can see how we can implement two pointers there.